Hi, fourth grade students and family members, it's Mr. Panza again, focusing on this question. How do we use bar models to answer word problems? Another way we've been asking that question is how do we solve real-world multiplication problems? Tonight for homework you have two questions. One is number 3, talking about mashed potatoes collected, and number 4, Mrs. Novak needing 2-liter bottles of Coke. Tonight, I'm hoping that I can help you not only solve these problems, but help you work out the different bar models to show you how beneficial using a bar model can be when solving real-world multiplication word math problems. First thing I need to do is read the question and know what I have. Mr. Panza's class collected 12 boxes of mashed potatoes. Mrs. Grazer's class collected 5 times as many as Mr. Panza's class, and Mrs. Riley's class collected 3 times as many as Mr. Panza's class. The main question that ultimately I'm trying to answer is this right here. How many more boxes did Mrs. Riley and Mrs. Grazer's class collect than Mr. Panza's class? I can't jump ahead and just answer that question. I've got to take it piece by piece. So if I separate my page into math work and a bar model, you're going to see the benefits of using the bar model. First, I take what I know, and that's the fact that Mr. Panza's class, who we will represent with this blue box here and the letter P, has a certain number of mashed potatoes, and that number is 12. I received that information right here. When I went back into the problem, I saw that Mr. Panza's class collected 12 boxes of mashed potatoes. That becomes my base number. My base number is the number that's going to go in every single one of my bar model boxes for this equation. Then I look at Mrs. Riley's group. We represent Mrs. Riley in red. Riley's class collected 3 times as many as Mr. Panza's class. So I'm going to represent Riley with the red boxes and a red R. And I recognize that each of these boxes in my bar model represent the number that Mr. Panza had, which was 12. But Mrs. Riley didn't just collect 12, she collected 3 times as many. The reason I like using the bar model is now I understand that multiplication is nothing but repeated addition. So I have 12 plus 12 plus 12, which I could do in a different way. If I was trying to figure out Mrs. Riley's total, repeated addition is multiplication. In other words, 12 times 3. When I multiply 12 times 3, I get 36. So this mustache here would tell me that Mrs. Riley's total is 36, and Mr. Panza's total so far doesn't change. That's what we knew. It's our base bar model 12. Now I just need to solve for Mrs. Grazer's box. For Mrs. Grazer, I create green, and I go back into the question. Mrs. Grazer's class collected 5 times as many as Mr. Panza's class, which is why there are 5 boxes. And we know from the equation above that in each individual bar, there are 12. And this should help me recognize that, oh, with each bar, I'm doing nothing but repeated addition. 12 plus 12 plus 12 plus 12 plus 12. In other words, to figure out how much Mrs. Grazer has, I take 12 and I multiply by 5. Because she collected 5 times as many as Mr. Panza's class. And when I multiply 12 times 5, I get 60. That's still not my equation, however, because I draw my mustache to show my total for Mrs. Grazer as 60, and I've got to go back to the main question. How many more boxes did Mrs. Riley and Mrs. Grazer collect than Mr. Panza? So I need to total Mrs. Riley and Mrs. Grazer's class to help solve this problem. 60 plus 36 is 96. That's the total of Mrs. Riley's class and Mrs. Grazer's class combined. In order to tell the difference between their 2 classes and Mr. Panza's class, I just subtract 12. 6 minus 2 is 4, and 9 minus 1 is 8. And anytime I'm multiplying, I'm adding, I'm subtracting, I'm using my touch points to solve. So my answer for this equation is that Mrs. Riley's class and Mrs. Grazer's class each collected 84 more boxes of mashed potatoes more than I did. I shouldn't have said each. I should have said their combined total was 84 more than Mr. Panza's 12. Going down to question number 4, I've set up my bar model a little bit differently to represent the total number of boys in Mrs. Novak's class and the total number of girls. Mrs. Novak needed 2-liter bottles for a science project. There are 7 boys, which are represented not only in the bar models, but also in my picture representations, as well as 8 girls in her class. So I have a picture of 8 girls and 8 bars representing each girl. If the boys from her class each brought in 5 bottles, and the girls in her class each brought in 6 bottles, how many total bottles did her students collect in all? Well, in order to do this, I'm overall going to have the 7 boys in her class and the 8 girls in her class, and eventually multiply the 7 by however many each boy brought in, which is 5. And for the girls, the 8, they each brought in 6. But that's what's great about bar models. If you do not see that, oh, I have to multiply these 2 equations and then ultimately add them together to answer my question, the bar model is going to help you out. I can take a look at my bar model and understand that there are 7 boys in Mrs. Novak's class, then go back into my question and recognize that the 7 boys each brought in 5 bottles. So every single bar should have a number 5 in it to represent how many that each boy brought in. And then, because I know that multiplication is simply repeated addition, I just need to take these 5s and add them. 5, 10, 15, 20, 25, 30, 35, which means the boys brought in a total of 35 2-liter bottles of Coke. And then I do the same thing for the girls. If I don't automatically see that I just need to do 8 times 6, well then my bar model will help me out because I take a look at each individual girl, which there are 8 in her class, and each girl bringing in 6 is the number that I put in each box. Each box is the same exact size because they brought in the same exact number, and you notice that the girls' box goes 1 deeper than the boys because not only did they bring in more, but there are more of the girls. And I know my 6 times table song, so I can just sing that to get my answer for how many the girls brought in. Sing it with me. 6, 12, 18, 24, 30, 36, 42, 48. Then I stop. That tells me that there are 48. In other words, I could have multiplied 8 times 6 and got the answer 48. I could have multiplied 7 times 5 and got the answer of 35 and then added. But the point is, sometimes the questions are easier to see with picture representations like bar models. So when I add 8 and 5 using my touch points, I start with my largest number 8 and I add my 5 touch points, 9, 10, 11, 12, 13, carry my 1, bring down my 3. I start with my largest number 4 and add my 3 touch points, 4, 5, 6, 7, 8. That's going to tell me the total amount of 2-liter bottles of soda that Mrs. Novak's students, boys and girls, brought in for the project. So those are the answers, but a more important fact is that I want to make sure that each of the students are copying down the bar models. They don't need to draw pictures of boys and girls, but the bars are important to represent the fact that they understand that multiplication is nothing more than repeated addition. And that is how you use bar models to answer word problems. I hope this helps.